Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers proofs. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Okay, question 4. The base of a pyramid has n sides. Circle the expression for the number of faces of the pyramid. Okay. Well, let's have a think about this. Let's start off with a square base pyramid, which has got 4 sides. Now, pyramids, each of the corners of your base of your shape will join up to a point on the vertex. So that's how you draw a pyramid. So basically, you get a triangular face joining on to each of the edges of your base. So there's one triangle. Second one will be there, and so on. So there will be, for this square base pyramid, there will be 4 triangular faces plus the base of the pyramid itself, giving you a total of 4 plus 1 or 5 faces. So for a shape that's got n sides on the bottom, you're going to have n triangles plus the base. So it's going to be n plus 1. Question 9. Circle the expression for the range of n consecutive numbers. Okay, so first off, what does range mean? Range means highest minus lowest, doesn't it? So range equals highest value minus the lowest value. Okay, now let's consider our n consecutive numbers. Now we don't know what the first number is, so let's call it a. Now my next number is going to be 1 more than that because these numbers are consecutive, so I'm going to have a plus 1. Then I'm going to have a plus 2, and then so on. Now what's my last number going to be? Now it's not going to be a plus n, because that means I would have n plus 1 numbers. So it's got to be a plus n minus 1, giving me n numbers altogether. Okay, so then if I take my highest number, a plus n minus 1, and take away my lowest number, a, then my range is going to be a plus n minus 1 take away a, which is n minus 1. So it's that one there. Cross section of a prism has n sides. Circle the expression for the number of edges of the prism. Is it 2n, 3n, n plus 2, or is it 2n plus 3? Okay, let's just think about an example first. If I had n is equal to 4, so a 4-sided cross section, otherwise it's some kind of cuboid, then those bits would all be straight, wouldn't they? And then the pattern would repeat at the end. So how many edges would I have? I'd have my n edges, my 4 edges around here, and then I'd have an edge for each of those lines heading that way for each of my 4 corners. Plus I'd have another 4 edges down at that end. Okay, so I get 4 plus 4 plus 4, 3 lots of 4. Okay, now if I then had 5, so it was like a pentagonal prism, same thing, and then that went down like that, and I had another pentagon at the back. Can't draw pentagons very well, but you can see again, I'd have, there are my 5, and there's 5 here, so I'm going to have 5 edges on the front face. I'm going to have 5 edges run in between them, and I'm going to have another 5 edges on the back face. So basically it's going to be 3 times the number of corners on my front face, isn't it? So whatever n is, the answer of the number of edges is going to be 3n. W, x and y are 3 integers. W is 2 less than x and y is 2 more than x. Prove that wy plus 4 equals x squared. Okay, well, if w is 2 less than x, then w must be equal to x take away 2. And if y is 2 more than x, then y must be x plus 2. So wy plus 4 is going to be equal to x minus 2 times x plus 2 plus 4. Doing FOIL on this brackets, if you don't know the identities, would give you x squared. You're going to get minus 2x plus 2x are going to cancel each other out. Minus 2x plus 2x, which cancel. And then minus 2 times plus 2 is minus 4 plus 4. And then you can see that these cancel each other out as well. And it just leaves you with x squared. Question 21. Prove that 5n minus 2n plus 3 times n plus 1 is always negative. Now clearly we don't know what n is. N could be any value, so on the face of it, it's not clear why that would always give me a negative number. Let's try multiplying out the brackets. So we'll do FOIL on these. Just take care because this is a minus sign here, so basically the signs are going to flip for everything that we get when we multiply out this double bracket, and then simplify it and see what we've got. So I've got that's equal to 5n. So I'm going to have 2n times n, which would be 2n squared. Because of the negative sign, it's going to be minus 2n squared. And I've got 3 times n, which would be positive, but because of the minus sign, it's going to be negative 3n. And then I've got 2n times 1, but would be 2n, but because of that minus sign, it's going to be minus 2n. And finally, I've got 3 times 1, which would give me plus 3, but because of the minus sign, it's going to give me minus 3. So, collecting like terms, 5n take away 3n take away 2n. Well, they're going to cancel each other out, aren't they? So that cancels with these two. And it just leaves me with minus 2n squared minus 3. Now, n squared is greater than or equal to 0 for all values of n. Because if you square a number, if it's negative, a negative times negative is positive, and a positive times positive is positive. So you're always going to get a positive number unless, of course, n is 0, in which case you're going to get 0. So n squared is greater than or equal to 0 for all values of n. So minus 2n squared is going to be less than or equal to 0. And then if I then subtract 3 from that, minus 2n squared minus 3 is definitely going to be less than 0, isn't it? Question 20. Prove that 3 lots of x plus 1 times x plus 7 minus 2x plus 5 all squared is never positive. Okay, it's quite difficult to see why that might be the case in its present form, but perhaps if we multiply it out, it'd be a bit clearer. So let's take the expression and do some maths on it to make it a little bit clearer what's going on. So first off, let's multiply out this first bracket here. I've got x times x, which is x squared, 1 times x, which is x, and x times 7, which is 7x, give me a total of 8x in the middle, and 1 times 7 is 7. And I need to subtract, well, it's going to be 2x. Let's just write that second bracket out so we can see what's going on a bit clearer. So 2x times 2x is 4x squared, 5 times 2x is 10x, and 5 times 2x is 10x, give me 20x in the middle, plus 2 lots of 5 times 5, which is 25. Okay, so multiplying everything in the first bracket through by 3 I'm going to get 3x squared plus 8, 16, 24x plus 21. Now everything in that second bracket needs to be negative, so it'd be minus 4x squared minus positive 20x is minus 20x, and minus positive 25 is minus 25. 3x squared take away 4x squared is minus x squared. 24x take away 20x is plus 4x, and 21 take away 25 is minus 4. Okay, now we're going to try and see if we can factorize this, but let's just take out a minus sign first to make it a bit easier for ourselves. It's a bit difficult to factorize with a negative x squared, so I'm going to just remove a minus sign from each of the terms and put it at the front. Now, can I think of two brackets that factorizes into? So if I put an x there and an x there, I'm looking for numbers that multiply together to give you 4 and sum to minus 4. So I think I know what those are. That's minus 2 and minus 2. Minus 2 times minus 2 is plus 4, and you add it together you get negative 4. So that gives me minus x minus 2 all squared. Okay, so why is this number always negative? Well, if I take a value and I square it, I'm going to get a positive value or 0. And then so if I stick a minus sign in front of that, I'm going to get a negative value or 0. But what I'm going to get is never going to get is a positive value. So this is, so minus x minus 2 all squared is less than or equal to 0 for all values of x. Question 26. I've been given the identity a squared minus b squared is identical to a plus b, a minus b. You might recognize that. That's the difference of two squares identity. You should definitely know that one. And then I'm told that a and b are positive whole numbers where a is greater than b. And I'm also told that a squared minus b squared is a prime number. And the question is, why are a and b consecutive numbers? Right, this is quite a tricky question, really. Well, it's going to take a little bit of thought how to answer it. Let's start off by thinking about prime numbers and not prime numbers. Now, if I've got a prime number like 5, I can express 5 as two numbers as a product only by multiplying 5 and 1 together, can't I? Because 5 times 1 is 5, and there are no other factor pairs for 5, which is why 5 is a prime. But a number like 6, I can write as 6 times 1, but I can also write it as 3 times 2. So what makes a prime is that if I've got two numbers that multiply together to give you that number, then one of them has to be 1. Otherwise, it's not a prime. So let's have a look at what we've got here. We've got a squared. So if a squared minus b squared is identical to a plus b, a minus b. So, and we're saying that this thing here, this a squared minus b squared is a prime number. So if this is prime, then it must mean that a plus b and a minus b, one of those things must be the number 1. Now let's have a think about a plus b. Now we're told that a and b are whole numbers and a is bigger than b. So the smallest a can be is 2 and the smallest b can be is 1. So the smallest a plus b can be is 3, isn't it? It's going to be a number larger than 3. So it's certainly bigger than 1, isn't it? So what about the other one? So that first part there can't be the 1. That means that the a minus b has to be the 1 if it's going to be prime. So a minus b needs to be equal to 1 if a squared minus b squared is a prime. So it must be that a minus b is equal to 1 if a squared minus b squared is a prime, because if it's not 1, then we've got a different factor. We've got another factor pair, so the number can't be prime. So if a minus b is 1, that means that a and b must be consecutive. So, and if a minus b equals 1, then a and b must be consecutive. If the difference between the two numbers is 1, they must be next to each other, mustn't they, on the number line? Okay, and I think that's sufficient to get those 2 marks then. Question 20. N is a positive integer. Prove algebraically that 2n squared times 3 over n plus 6n lots of n squared minus 1 is a cube number. Ooh, okay, let's give it a go then. Where to start? I suppose we could start by multiplying out these brackets, couldn't we? And then have a look at what we've got. Okay, so they look pretty horrendous, but let's see what we get. 2n squared times 3 over n. Well, 2 times 3 is 6. So I'm going to get 6 is my kind of coefficient. And then I've got n squared times 1 over n, which is basically n squared divided by n, isn't it? So that's going to give me 6n. And then if I multiply 2n squared by n, I'm going to get 2n cubed. Plus, what am I going to get from the second bracket? 6n times n squared. That's going to give me 6n cubed. And then I'm going to get 6n times minus 1, which is minus 6n. Okay? So I can immediately see I've got a 6n at the front and a 6n at the back with different signs. They're going to cancel each other out. And that leaves me with 2n cubed plus 6n cubed, which is 8n cubed. Okay? Now, a is a cube number. A is 2 cubed. So I could rewrite 8 as 2 cubed, in which case I've got 2 cubed n cubed. And 2 cubed n cubed is the same thing as 2n all cubed, isn't it? Index of an index. If you have something in a bracket like that and raised to a power, you have to raise each thing inside the bracket to that power. So it's 2n all cubed. In other words, the answer has to be a cube number, because whatever n is, you're going to end up with doubling it and then cubing it, which is going to be a cube number. So therefore, always a cube number. Ta-ta! Question 27. Prove algebraically that 2.75 recurring converts to the fraction 124 over 45. Okay, so what does 2.75 reoccurring look like? It's 2.755555 and so on. Okay, let's make that equal to x. Okay. Now, if x is 2.75555555, then 10x is going to be 27.55555, and 100x is going to be 275.55555. Yeah? These go on forever, don't they? So if I then take 100x and I subtract 10x, what I'm going to get is 275.55555 minus 27.55555 and so on. So what is that then? Well, 100x take away 10x is 90x, and 275.5555 minus 27.55555, you can see that these are going to cancel with those, so we don't have to worry about all the recurring 5s now. And 275 subtract 27 gives me, what's that, 250, 248 then, isn't it? 248. Okay, so then my value of x, just dividing both sides by 90, is going to be 248 divided by 90, which is a fraction. Can that fraction cancel down? I'm just going to type it in using the fraction key on my calculator and see if my calculator will find any. Oh yeah, there we go. Simplifies to 124 over 45, spookily. 124 over 45. Okay, so it works then, doesn't it? We've shown that it converts to 124 over 45. Now, question 21 starts talking about Mersenne primes. Now, before you go and start complaining to your maths teacher that they've never mentioned Mersenne primes to you, don't worry about it. You're not meant to know what they are. They go on to explain what Mersenne primes are. It's not assumed knowledge for the test. So Mersenne primes are prime numbers that can be written in the form 2 to the power n minus 1, where n is a whole number. So 3 can be written as 2 squared minus 1, so 3 is a Mersenne prime. So we need to prove that 2 to the power 9 minus 1 is not a prime. Well, what is 2 to the power 9 minus 1? 2 to the power 9 is what? 2, 4, 8, 16, 32, 64, 128, 256, 512. So 2 to the 9 minus 1 is 512 minus 1, which is 511. Is that not prime? Now, well, if 511 is a prime, then it's clearly a Mersenne prime, but is it a prime? Can you think of any numbers that multiply together to give you 511? Well, I don't know actually. Let's see if we can find out. Well, I know it doesn't divide by 2 because it's not even. It doesn't divide by 3 because 5 plus 1 plus 1 is 7, and that isn't a multiple of 3. It's not going to divide by 5 because it doesn't end in 0 or 5. So let's see if it divides by 7. 511 divided by 7. It does. 511 is equal to 7 times 73. So it's not prime. Okay. Next part of the question says there are Mersenne primes where n equals 5 and when n equals 7. Amma says the ratio of the indices is 5 to 7. This means that the ratio of the Mersenne primes is 5 to 7. We need to show that Amma is wrong. Okay, so we need to work out what these numbers are then, don't we? So if n is 5, then so for n equals 5, 2 to the power n minus 1 is 2 to the 5 minus 1. 2 to the 5 is 2, 4, 8, 16, 32. 32 take away 1 is 31. And for n equals 7, 2 to the n minus 1 is 2 to the 7 minus 1, which is going to be 32, 64, 128. 128 minus 1, which is 127. Okay. Well, 31 to 127, that's not going to be equal to 5 to 7. Now these are prime numbers, aren't they? So you can't cancel them down. You're not going to get 31 to 127 to cancel down to 5 to 7. So that isn't going to work. Question 9. Noah is attempting to work out the base of different right-angled triangles. Here is his method for working out y is equal to 10 and x is equal to 6. So he first works out y squared. In this example is 100. Then he works out x squared. In this case is 36. Then he subtracts one from the other, and then he square roots them. This is basically Pythagoras theorem, isn't it? So underneath it says tick the correct statement. The method will always give you an answer which is a whole number. The method will sometimes give an answer which is a whole number. The method will never give an answer which is a whole number. Well, his first example here with x and y equals 10 and 6 gave us root 64, and root 64 is 8, so that is a whole number. So that particular example does give a whole number for the base, but if you've ever done any questions with Pythagoras theorem before, you'll know that that is a rarity. The Pythagorean triples are the ones that give you nice whole numbers, otherwise they are decimals. Now, it asks here that we need to show our working, or show working to support our answer. So we need to give some examples of why we would pick this one. This is obviously the correct solution that sometimes gives us a whole number. But let's give some examples. So when y is 10 and x was 6, we had a triangle that looked like this: 10, 6, and so our base then was going to be root 64, which is 8. But when y, and then we just change one of the values, I suppose. So let's change y to 8 and leave x equal to 6. Then the base is going to be equal to square root of, the square of 8 is 64, so subtract the square root of 6, which is 36, square rooted. 64 subtract 36 is 28, and that is a decimal. And that is a whole number. So just giving an example of where it does happen and where it doesn't happen is enough supporting method to highlight that middle statement there. Question 27. Prove that x squared plus x plus 1 is always positive. Now, there are quite a few different ways of going about this. The way I think I'm going to look at it, I'm going to think of this as a quadratic equation: y equals x squared plus x plus 1. Now this is, everything's positive, isn't it? So it's going to be a kind of a smiley parabola this way around. And if it's always positive, it means it is always above the x-axis. Don't know where the y-axis will be. So how can we prove then that that quadratic curve, or that parabola, is always above the x-axis? Well, if we can find this point here, the lowest point on the curve, and show that that is positive, then we can, well, we can say that x squared plus x plus 1 is always positive. So how do we find the turning point of a quadratic? We need to complete the square. So rewriting this as x plus something squared. The something squared you get from looking at the x term here, don't you? It's the coefficient of that term divided by 2. So the coefficient of x here is 1, and taking 1 and divide it by 2 gives you a half. Now if I want to replace x squared plus x with x plus a half all squared, I'm introducing a half squared more than I should, so I need to take that off again. Plus I've got my 1 from before. So that is equal to x plus a half squared. Well, minus, what's a half squared? A half times a half is a quarter, plus 1. And that gives me x plus a half all squared. What's minus a quarter plus 1? 1 take away a quarter is 3/4, so that's plus 3/4. Okay, so then this graph here then is going to have, so graph has a minimum point at, well, what's the x coordinate and what's the y coordinate? The x coordinate is given by this part of the expression. It's the value of x that makes that bracket equal to 0. So if I let x be minus a half, then minus a half plus a half be equals 0, and 0 squared would be 0, and that would be the least possible value of that expression. And if that bracket were 0, then this part here would be our y value. So our y coordinate is going to be 3/4. So this point up here then is minus a half 3/4. And you can see then that 3/4 is going to be the lowest value that the expression can take. And therefore every value of x squared plus x plus 1 is always going to be that value or more than that value. In other words, it's always going to be positive. So how can I write that down? So x squared plus x plus 1 is going to be greater than or equal to 3/4 for all values of x. Not sure that's why that's there. All values of x. So x squared plus x plus 1 is always positive. And question 90. The diagram shows that a triangle and a trapezium, and we need to prove that A is equal to B. Okay. Let's have a look first at this selection or collection of angles here. Now here we've got angles at a point, and angles at a point sum to 360 degrees. So we know then that all those things together must be equal to 360. So A plus 65 plus C plus 115 degrees is going to be equal to 360. So A plus C plus 65 plus 115, that's 180, isn't it? So, and then taking that 180 over to the other side to simplify things a little bit, I'll get that A plus C is equal to 360. Take away 180, which is just 180 degrees. Okay, so that's my first equation. Now, what else do we know? We've got C and B, which are angles sitting inside a parallelogram, a trapezium. Now notice that these two sides are parallel, this one here and this one here. So C then and B are supplementary angles, they sum to 180 degrees. So we know also that B plus C is equal to 180 degrees. Okay, now comparing those two things, if A plus C is equal to 180 degrees and B plus C is equal to 180 degrees, that means that A must be the same thing as B. Okay, so we've got a rather complicated looking diagram here. We're told that ABCD is a parallelogram, and we're told that CE equals CF, which basically means that that triangle is isosceles. And we need to show that x equals y. Okay, so we need to work out the relationship with those two given angles. Now, what we're going to have to do then is we can start with this angle down here, the 2x. Now we know that opposite angles in a parallelogram are equal, so that one's going to be 2x as well. Why did I write down y? 2x, and then we can use angles at a point being equal to 360 to find that angle inside the isosceles triangle, and then we can then work out what the tips of the isosceles triangle are. So that's my basic strategy. Okay, let's start writing that up. So now the angle with the 2x in it, which is angle BAD, is equal to the other opposite angle in the parallelogram, which is angle DCB. Just going to write opposite angles in parallelogram. And then we can say that then 2x plus 90 plus 90 plus angle ECF is equal to 360. That's from angles at a point. So that means ECF, angle ECF, is going to be 360 minus 90 minus 90, which is 180, is 180 minus 2x. Okay. Right, so now we know that ECF, which is the top of our isosceles triangle, is 180 minus 2x. We can say that angle CEF, which is the angle we were looking for, angle CEF, now that is going to be, well, 180 degrees minus the angle at the tip, minus 180 minus 2x, divide by 2, because it's an isosceles triangle. So 180 minus 180 minus 2x is 2x over 2. So CEF equals x, but we're also told that it's equal to y. So therefore x equals y. Question 16b. M, N and S are points on circle C1. So you can see they're all on the circumference of that circle. RST is a tangent to C1, and circle C2 passes through the center O, S and M of circle C1. And we need to prove that SM is not a diameter of the circle C2. Okay, so where is SM? SM is this line here, isn't it? Okay, there's my line SM. Now, if it was a diameter, then it means it would pass through the middle of the circle. And it also means that any angle I subtended from it would have to be a right angle, because an angle subtended in a semicircle is a right angle. So if SM was a diameter, then that would have to be 90 degrees. Now, if that was 90 degrees, then this angle here must be half of it, must be 45 degrees. But is it? I don't think it is, because I've got a tangent here and an angle subtended between that tangent and a chord. So then the angle subtended in the alternate segment must be equal to it. So that angle up there must be 48 degrees. So if that is 48 degrees, then that center angle there is going to be twice as big. 48 times 2 is going to be 96. I don't want to keep writing in blue. So that angle there must be 96 degrees. And therefore SM cannot be a diameter because it's not a right angle. Okay, so we need to write that all down now. So let's start with let's work backwards. So let's start with the tangent and working out what the angle at N is. So RST is a tangent, and therefore SNM, the angle, must be equal to 48 degrees because of the alternate segment theorem. which means then the angle at the centre, SOM, is twice that. It's going to be 48 times 2, which is 96 degrees, and that is because angles subtended at centre are twice angle subtended at circumference. So you have to learn these rules really, so you can write them down like this, and then so now we're saying that SM, if SM was a diameter, then SOM would be 90 degrees, and that is because of angles in a semicircle are right angles, and it's not, and it is not. So SM is not a diameter. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.